is Riley. This is my 5th time recording this, and hopefully it goes correctly. I work with the DAO and I write code. I don't usually record videos. This is a tutorial on how to deploy Fracada to the mainnet of Cardano. Now, the first step is you're going to need to have nix-shell installed. This is all inside of here. I'll put some stuff in the description, but you'll need nix-shell installed, and you'll enter into nix-shell from Plutus. And basically what that looks like is you're going to go into your Plutus directory. You're going to run nix-shell. I should have just kept it up. It takes a minute, but for sake of education, might as well do this. Something else I'm going to mention while I'm at it is you do want to set up your Cardano node as well. So your Cardano node could be dataless, or it could be a Cardano node that's running without some sort of application you can click into. It might just be accessed here. I choose to run dataless and then point this thing, the Cardano node socket path, to dataless. And what that allows me to do is then run this thing called the Cardano-cli, and I can do like query on this address, right? And so if I do that, I can see the assets that are here at this address, and I find that there's this one. We're going to use that for fractionalization. Now we're over here again waiting. Just click out of that for now. And what we're going to do is we're going to actually cd out of, cd means change directory, to be clear. We're going to move out of there, and we're going to go into the Fracada contract. Now this is exactly the one that DC Spark has available here. I have not changed anything. It is exactly the same code. And what you're going to want to do is you're going to run cabal run script dump, and then you're going to need to enter in the information on your deployment. They don't have it here. Shoot. Oh, they do. Currency symbol, token name, fraction token name, and number of fractions. So in our context, we grabbed that thing over there, and we're going to use the plain text name. We'll use another, maybe we shouldn't. There is going to be a step where this may fail, but we'll use DAO fraction as the new token name, and we'll do 100 of them. So at this point, we wait for the code to compile. Hopefully this tutorial goes smoothly. If you ever run into any issues, feel free to drop into the DAO Discord. I try to be pretty responsive there, and I'm always happy to help people out. But we'll see how this goes. Something that people should be aware of is that the current state of Fracada does require that you compile the contract every time. It's not necessarily compiled, but yeah, you have to run this script dump file somewhere, right, on some server. You don't necessarily need to compile anything new, but you do need to serialize your parameterized contract. And so with that, I mean, there's definitely operational overhead. I've been thinking a lot about ways that we could potentially move that process into the browser. I think it's possible. I don't think it would be a lot of fun, and I've never made a WebAssembly module before, so anyone out there who wants to do it, feel free. Let me know when you do. Sweet, we're finally compiling Fracada instead of just grabbing resources. And even after this, we'll have to compile the script dump files. So had I done this, had I run this command previously to doing this tutorial, it probably would have been beneficial, but we'll get through it. Now, we've got our files, and what we're going to do is we're going to actually exit out of nix-shell at this point, and you can see we're in this Plutus repository. And so what we're going to do is we're going to go all the way back to our home directory, and we're going to export that Cardano node socket path because this is a different terminal instance. And at this point, we can run our Cardano CLI commands, right? And so what we're going to want to run first is we're gonna take this. We're gonna want to do an address build, right? And basically, there's a bunch of different commands in here. If you just run the CLI command, you'll get like an overview of all the commands. If you run the CLI command and then run address, you'll see what you have available here. And what we're actually going to want to do is we're going to want to build an address, and we're going to want to build an address based on a payment script file, and the payment script file is located in dc/fricata, and then it's this validator.plutus file. And instead of using testnet magic 8, what we're going to want to do here is we're going to run mainnet. And so what that does is it creates this address, and this is the address we're going to be locking our NFT in, right? This is our script address. And so what we're going to need to do is construct a transaction. Now, what that looks like in the Cardano CLI is we're going to have this you're going to have this transaction build type command, and you're going to use the Alonzo era, as you can see right here on the mainnet, with a protocol params file. Now this protocol params file you can generate with another command, and I'd have to look that up really quick, but it's not a big deal. I mean, you basically need to go get those params. This is the command you'd run: query protocol parameters mainnet. You'd use Alonzo era here instead of Allegra. We're not in Allegra anymore. But yeah, so basically what we're going to want to do is we're just going to want to use the same sort of template as you see above to build this transaction. And so we'll do build Alonzo era mainnet protocol params file pparams.json. Now this slash that's leaning backwards allows us to enter a new line, and this is where we're going to put our TX ins, right? So we got TX in, and what we can do is we can open up another terminal tab. So you see I've got terminal here, I've got terminal here, and I can come in here and actually query my address again, like we did before. And what we're going to want to do this time is we've got, remember, this is the NFT we want to use. So this is our transaction output, or this is our transaction hash, and it's the index 0 is going to be the index. So we've got a TX in. Oh, shit, I don't want to copy 0. And then we just do number 0. So at the end here, we say number 0 to denote the index on that transaction hash, and say that it was index 0. And so we'd use number 1 if it was this, if this was the UTXO we were using. And so after we have that, then we're obviously going to need to we're going to need to mint. So what I'm going to do is actually exit out of that, and we're going to go back up. I know this is silly, but I definitely don't remember all of the inputs. Nobody should feel like they need to memorize all of this stuff. I've done it enough to where I can go backwards in my command prompt a lot of the times and find stuff that's helpful. So something that I'm looking for right now is actually minting. So we've got this minting, right, in the minting script file. And we also are going to need to do embedded datum. And so you've probably see, down here, we've got the TX out datum hash, for example. That's one way to do this. I think that there was other TX out embed, right? So you can embed the datum file that way. But yeah, you don't have to necessarily do it any one way. You can say in values or yeah. Anyway, back to the main point. What we want to do is we want to run this this command to build a transaction. Right, and so the only TX in that we're going to use is here, and then we're going to need a collateral TX, right? So we're going to use this for collateral, and that's also index 0. And then what we're going to need is to do TX out, right? So we've got this TX out, and here is where we're going to need to use the address we built, so we can rebuild it again if we want to. See right here, same command, same address, always going to be that way. This is deterministic. Now what we're going to do is we have that address, and we're going to add, what do we say? I'm just going to take the same amount that's on here. Maybe give it, yeah, let's do that. And then I'm going to say we want one of those plus one of those. And then what we'll need is we'll want to come in here and we'll say change address. We'll give our own address for that. We want to send our change back to ourselves. And then we're going to have a minting value. Ooh, shit. You know, actually, prior to this change address, you're probably going to want to add your TX out for yourself, right? And so what I am actually going to do here is I am going to I'm going to start running this over again, and so it'll just be a second for me to do that. But basically, it's really easy to mess up this process, and so manually crafting transactions like this is not the way that you should probably be interacting with smart contracts. The way that you really should be interacting with smart contracts, and I'll post a tutorial on this in the near future, is through web integrations, right? So there's a WebAssembly module out there from Emergo that's written in Rust, but that's now this needs a TX out datum, right? This needs a datum. Shit. Whoo-wee. Again, we can do transaction build, and what's nice is this actually does show us all this stuff, and so we can come in here and we can say we want TX out datum hash value. Now this is the script datum hash for this TX output by hashing the script datum given here in JSON syntax. There's no schema. Okay. So what we can do then is we can literally come in here and we can say we want to do a TX out datum hash value, and we can come and just throw a 42 in here. I think this might not work, but I think this should work. May need to throw quotations around that. And then we can begin another one of these. And our next one is going to be our own address, right? But what we're going to want to do is actually do like another one of these plus 100 of our new thing. So what we can do is we can actually look into our folder here and go to the currency ID text, right? We want to open that up. Now this is nice because what we can do is we just grabbed our currency ID, or our policy ID if you want to call it that, and we have a DAO fraction. Now I can take that and then I can say that we want to mint. Ooh, but now actually I need the change address. Yeah, so we'll grab that. And then you're gonna want to do mint 100 of our, not our change address. We don't want to mint 100 of those. We want to grab the token here again. Oh shit! And actually, we're not gonna wanna do it like that. We're gonna have to rewrite this. This cannot be a DAO fraction. We need to serialize that first. And so we'll mint 100 of those bad boys, and we'll have to change it in here as well. But a DAO fraction, and then we should be able to do mint redeemer value. We don't really need a typed redeemer because it doesn't matter what the redeemer is. Minting script file is going to be git /dc /fracata, and we're going to use their minting.plutus file right there. Okay, and so then what we do is we come in here and we say out file, and we'll do fracata.raw. Now, like I said, we needed to serialize this a DAO fraction thing here, and so what we can do is we can actually take this, ASCII to hex. And so we get this output here that we can use, and what we're going to want to do is just go back up, and obviously if you can, it would be nice for you not to have to waste your time the way that I did going through this again, but you can come in here, change this out. Hopefully that's a nice way to do that. Like I said, definitely not the most user-friendly way to interact with smart contracts. You're going to want to use web interfaces that people develop in order to do this. You do not want to be deploying your smart contracts like this, but it is the way that early smart contracts were done, and this is how, you know, if you were wanted to be participating in like the lobster contract that Lars put up right when we had our hard fork. It's relevant. Now, what we do need here is we do need a minimum required that's higher than what we have right now. So what we can do is we can come in here and throw in additional, right? So we can come in here and just say give it 7. Maybe give this one 7 as well, just for the heck of it. We need to balance our use of ADA. So since we're negative on our ADA usage, we need to include another UTXO. And so we'll query our address again. Do we have another UTXO that we can use? We do. We have this one, C, right here. This is transaction hash plus 0. So what we can do is we can literally just come in here and we'll just say we're going to drop down. Oh, shit. Excuse my language, by the way. But we'll do tx in throw that there, hashtag 0, boom. We just got a raw file there, right? And so what we're going to want to do now is we're going to want to sign this thing. And so what that looks like is you're going to do something that looks like this, and I'll write it out again, but you're basically, again, using transaction, and then it's a sign command, and we just are going to reference that file that we created called fracata.raw, and it's right here where we're working in the home directory. And so then we can just say that we want to use our signing key file, and it's the same wallet that was used for interacting with the Lobster contract. And so we'll use our payment.s key, right? And then what we do is we obviously have out file, and this is going to be fracata.signed. Now, once we've got our fracata.signed, what we can do is we can actually submit it. And what we do to do that is obviously we want to not use the testnet. Shoot. But it'll be the same regardless, or for everything else. And so we have this fracata.signed. Although it's looking like I may have just typed in fracata.si. No, we got it. So now we got a transaction submitted successfully. I don't know what the whole, oh, there it is, TX file. I saw SI somewhere. Here it is. It was a failed transaction. Okay, well, anyway, as you can see, the transaction was successfully submitted, and what does that mean? It means that if we come back over here and we query our address again, we're actually going to, in a moment, no longer have this. So we'll be able to query this a couple more times, and we will no longer have this NFT, and this is actually called the ADAO NFT. It's a test token that I minted, and I have another one in my wallet. But basically, this this token is fractionalized, and in return, we're going to get 100 of these tokens. So as you can see, it worked. We just did that, and we can also query the address that we used. So if we come in here and we say we want to know this address, right? That's where we that's the script address that we created. If we do cardano-node, cardano-cli query UTXO, and we use that address, the script address, obviously take off the added ADA, but we can see that there is a little bit of Lovelace, and then there's this NFT. And so we have successfully locked up an NFT and received our fractionalization tokens in return. Thanks for watching. If you have any questions, like I said before, drop into the AdaDAO Discord. We're always happy to help out, and happy coding.